Welcome everybody. Today we will start a new chapter, Understanding Quadrilaterals from your NCERT book, Class 8, Mathematics. So, everybody is there? Thank you. Okay. Last time we have discussed about the construction of quadrilaterals, and I have told you some properties of different types of quadrilaterals, like parallelogram, and within the parallelogram we have the rhombus, rectangle, and square, and the properties of their angles, their sides, and their diagonals. And sometimes back in one of your class, I've also asked you to find out about convex and concave quadrilateral. So today we will discuss that in detail. So let's start quadrilaterals. Understanding. Yes? Yes, I have done the recording. Yes. So note that a paper is a model for a plane surface. Okay, you know what is plane surface. In about 1 month when we were doing normal class, before this online class, I have told you about plane surface, okay? Plane surface, in plane surface, you will not have like solid surface. Solid surface means you have a ball, that is a solid surface, okay? And plane surface, it's like your paper. It is smooth and there is no upward and downward contour there. In your, if your table flat surface is also a plane surface. In plane surface, there will not be upward or downward contour. Okay, so it's just plane, like in your graph paper or in drawing your linear equation lines, in plotting the lines, they are all plane surface because it works only on the x and the y axis, okay, in the plane surface. There are z axis or g axis or z axis also for 3D objects. Z axis, okay, z axis. In z axis, suppose your whiteboard is a plane surface. If something is behind the black whiteboard or something is in front of the whiteboard, then we require z axis or z axis. Are you getting what I'm saying?
Yes.
So that will not be describable only by plane surface. Okay, that thing behind the whiteboard or in front of the whiteboard, but on the whiteboard, if a point is on the whiteboard, it can be described through the plane surface, through the x and the y axis only, but with reference to the whiteboard. Okay, if something is behind or something is in front, then we require z axis or z axis to describe the point, because it is not on the whiteboard surface or on the plane whiteboard surface. So in a plane surface, there will be no upward or downward contour. So you know that a paper is a model for a plane surface. A paper is a plane surface. When you join a number of points without lifting a pencil from the paper and without retracing any portion of the drawing other than single point, you get a plane curve. Is it right? say when you, without lifting your hand, okay, and without retracing, you get a plane curve, okay, a plane curve, like a C shape, or maybe a circle, a plane curve, okay. Try to recall different varieties of curves you have seen in earlier classes. Match the following. Let's check it out. Okay. Number one, everybody answer. Okay. Number one. This number one is which type? Is it a simple closed curve? Is it a closed curve that is not simple? Is it a simple curve that is not closed? Not a simple curve.
Number C. Simple curve that is not closed.
C.
D.
C.
What? C.
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 Yes.
You are saying
D.
it is simple curve that is not closed. Hmm?
Figure 1 is type D.
So you're saying it is not a simple curve. Okay, number three. What is number three?
Simple closed curve.
It's a simple closed curve. Simple closed curve. Why is it a simple closed curve? Number three is not a simple closed curve. Why? Number one, it is curve. Number two, it is simple. Sorry, it is closed curve. Why is it called simple? Is it why? Anybody please answer why it is called simple?
This one.
Okay, number three is curve. It is also close. It is also not close. It is also close. Sorry, it is also close. Why is it called simple?
Because it is.
Why is it not simple? Anybody please answer why is it called simple? Can I answer? Can I answer now? Can I say?
Ma, sumna laibagi circle amgi sumna laibagi thikoi na koi tau dabida koi daba harda number 2 ga 3 ga sidi ma simple oi de na.
I will tell you it is called simple because there is no crossing. There is no crossing. Okay?
Yes.
When you see number two, there is crossing. Correct? There is crossing. Okay? It is close. Number two is also close. Okay? Number two is also close. But there is crossing, so it is not simple. So number two is of type B. A closed curve. It is closed. That is not simple. Am I right? Listen, following? Everybody?
Yes. Yes.
So,
Yes.
number one, tell me about number one. It is not close.
Simple curve.
It is simple, but it is not close. So it will be
C.
of type C. Simple curve that is not close. It is called simple because there is no crossing. It is not close. So simple curve that is not close. And number four?
Simple close curve.
Not a simple curve.
Yes, not a simple curve. Not a simple curve because there is no crossing. Sorry, there is crossing. Okay, it's not a simple curve. So let us, everybody follow? Understood?
Yes.
Understood?
Yes.
Polygons. Let's start polygon, a simple closed curve. Okay, when you define polygon, it will be a simple closed curve. Number 4 is not polygon. Okay, number 4 is not a polygon. Okay, because not simple, there is crossing. The lines are crossing. So number 4 is not a polygon.
What about number 3?
Number 3, what about number 3? Is it a polygon?
No. No.
Why?
No.
Why?
Because it is not made up of line
Because-
segments.
It is because it is
Not made of line segment.
okay. A simple closed curve made up of only line segment is called polygon. Thank you. Correct. Because sometimes we can say that a very near definition of circle can be like a polygon with infinite line segment. Okay, small line segment can make up the circle. So by the standard definition, it is not a polygon. By the standard definition, okay. But theoretically, many line segments, small line segment can make the circle. But by the standard definition, it is given here that a simple closed curve. It should be a, what is a polygon? It should be a simple and again closed curve made up of only line segment is called a polygon. So from the above figure, which one of these is a polygon? 1, 2, 3, 4.
None of them.
Which one of them is the polygon? 1, 2, 3, 4.
None.
No one.
None of them. Because number 1 is not close. It is line segment. 2 line segments are there, but it is not close. 2 line segment cannot close. So it is made of line segment, but it does not cross. It is simple. Okay, it is simple. It doesn't cross. There are no crossing of lines, but it is not close. So 3 property are there. It should be simple, it should be closed curve, and it should be made of only line segments. So now 3 criteria are needed. In number 2, it's not a simple curve. It is closed, and it is again not made up of line segment. So again, number 2 is not polygon. Number 3, yes, it is simple. Yes, it is closed, but it is not made of line segments. Number 4, it is not simple. Though they are close, it's not simple and made of line segment, but though it is not simple, it will not be a polygon. Now, is this a polygon? This figure? Is this a polygon?
Yes.
Yes.
Yes, this is a polygon because it is simple. There is no crossing. Again, it is close. Again, they are made up of line segment. 1, 2, 3, 4 line segments. Okay. So it is a polygon. Again, this rectangle, again, this rectangle, the second and the third are rectangles. They are simple. There is no crossing. Again, they are close and they are made up of line segment. So these 2 rectangles are polygon. Now, like this one, there is crossing. Okay, so it's not simple. Somewhere it is close, made up of line segment, but though it is not simple, it is not a polygon. Again, the second one, there is crossing. Even though they are made of line segment, it's not a polygon. Again, the third one, it is made up of line segment and simple because there is no crossing, but it is not close. So this is not a polygon. Following? Everybody? Yes,
Yes.
or no?
Yes.
Please respond quickly. Okay, try to give a few more examples
Yes.
and non-examples for a polygon. Draw a rough figure of a polygon and identify its sides and vertices. Okay, you try to give more examples. Okay, as a homework, draw a rough figure of a polygon and identify its sides and vertices. You know that what are sides and vertices? Suppose this is a triangle. The sides are 3 sides. This one, and this one are called the sides of this polygon, namely the triangle. And vertices are this corner, this point, and this point are vertices, singular, vertex, plural, vertices. So this is a vertex, this is another vertex, this is another vertex, plural, but 3 vertices. Similarly, for the quadrilateral, 4-sided polygon, quadrilateral, these are the sides, 1, 2, 3, 4 sides. And the vertex, this point, this point, this point, this point. For the pentagon with 5 sides,
Tama nga.
yes, tell me.
WhatsApp tayo na photo am thagibne adu kano polygon oidoiro.
Okay, I will check it now.
Aina figure am gi
Will it be a polygon? Your question is the figure that you have drawn and sent through WhatsApp, whether it is a polygon or not. Okay, Albert, you have drawn this. Okay, Albert, this will not. This one. Okay, one by one. This are made up of lines. This is made up of line segments. Okay. This is close. Okay. Fine. And then this, even though it is not fully closed. Okay, you might say that the line doesn't cross. You might say, but it is not fully closed because some part is closed, but the other part is not closed. So it will not be a polygon. My reason will be it is not fully closed. Okay, it's not fully closed. Okay, Albert. Okay, Albert. Okay. Okay. Thank you. Now,
okay.
So for the pentagon will be 5 sides. We'll have 5 sides. 1, 2, 3, 4, 5. And the vertex are 1, 2, 3, 4, 5. So pentagon will have 5 sides and 5 angles because it has 5 vertex. Angle. This is one angle, another angle, another angle, another angle, another angle. So 5 sides, 5 angles. Similarly, for hexagon, 6 sides and 6 vertex or 6 angles. For heptagon, you will have 7 sides, 7 angles, 7 vertex, 7 vertices. 8 sides will be called octagon, and 9 will be nonagon, and 10 will be called decagon. And with n sides, it will be called n-gon. It will have n sides and n vertex. If n is equal to 3, it will be a triangle. If n equal to 4, it will be quadrilateral. If n equal to 5, it will be pentagon. If n equal to 6, it will be hexagon. N equal to 7, heptagon. N equal to 8, octagon. N equal to 9, nonagon. N equal to 10, decagon. N equal to 12, dodecagon, something like that. So suppose n equal to 30, it will be called 30gon. N equal to 1000, it will be called 1000 gon. If n equal to 1 lakh, it will be called 1 lakh gon. All right? All right?
Yes.
Yes.
So Quickly answer to my question. What is that polygon with 7 sides called?
Heptagon.
Correct. With 8 sides?
octagon,
Octagon.
Octagon.
With 5 sides?
Pentagon.
Pentagon.
With 4 sides?
Four sides. Oh.
Quadrilateral.
Quadrilateral.
Quadrilateral. Okay. With 3 sides?
pentagon,
Triangle.
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 With 2 sides?
Lady.
With 1 side?
line, line go on,
Line.
No.
Okay. So tell me the condition that is to be set to n. What should be the value of n for it to be a polygon?
any number,
More than 2 sides.
More than 3 or more.
So n should be in you tell me algebraically. Algebraically you tell me n greater than equal to 3, correct?
Yes.
Where n is a natural number. Okay, where n is a natural number. You know what is a natural number? Natural number
Yes.
starts from 1, 2, 3. There is no fraction. Okay, just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and goes on. That we cannot find the largest natural number, but the smallest natural number is
1.
1. So to give a criteria to n for the sides of polygon, n should be greater than equal to 3, where n is a natural number. Because if we have to say n is a natural number, because there are no polygon like 3 half side, or there is no polygon like 2.25 sides. So sides are natural sides. The number of sides is a natural number because it can be 3, 4, 5, but it cannot be 6.5. It cannot be 6.2. So you should define n as a natural number. Because it cannot be a rational, we cannot just say n to be a rational number. Even though 3, 4, 5, 6, 7, and 9 are also a rational number, but there are other rational number like 2.25, 3.1, which are not natural number. All natural numbers are rational number. Am I right? All natural numbers are rational numbers. Am I right? All natural numbers are rational numbers. Am I right?
Yes.
Because all the natural number can be written in the form of p by q, where p and q are integers and q not equal to 0. Because 1 can be written like 1 by 1, 2 can be written like 2 by 1, 3 can be written like 3 by 1, 4 can be written like 8 by 2 or 4 by 1, correct? So you have to define like say n greater than equal to 3, where n is a natural number. If you don't say n is a natural number, we are not very sure what type n is. We have to give some type to n that it is a natural number. Am I right? Are you following?
Yes.
So n greater than equal to 3, where n is a natural number. Now let's see what are diagonals. A diagonal is a line segment connecting two non-consecutive vertices of a polygon. This S and P vertices are adjacent because they lie adjacent to each other. These are called adjacent vertices, S and P. P and Q are adjacent. Q and R are adjacent. R and S are adjacent. But S and Q are not adjacent. P and R are not adjacent. We cannot simply say opposite. We cannot simply say, because in quadrilateral we can say, yes, in quadrilateral we can say, but like in this figure, what is this figure? Tell me, what is this figure? What is this polygon? What is this polygon called?
Pentagon.
Yes, pentagon. It has 5 sides. 5 vertex A, B, C, D, E. E, 5. It's not hexagon. Hexagon should have 6 sides. So in this pentagon, D and A, D, again D and B are also not adjacent vertices. So we cannot say just opposite, because the opposite to D can be A or B. So we cannot just say opposite. So just non-consecutive vertices. Okay. Are you following?
Yes.
Yes.
Thank you. So when we join two non-consecutive vertices, we get a diagonal. S join Q, then diagonal SQ. P join R, then diagonal PR. And I have told you earlier also, in naming the polygon, you should always use anti-clockwise direction, P, Q, R, S. Okay, not like P, S, R, Q. Okay, so P, Q, R, S. Okay, so
Yes.
again, so a quadrilateral will have two diagonals. Quadrilateral will have two diagonals. Let's look for the pentagon. How many diagonals can it have? For a pentagon, look, the like say D will play with A, D will play with B, something like that. So DA and DB, E again come to E, EC and EB. Okay, ठीक है. A AD is already completed. AD is already completed because DA we have done DA. So then AC, yes, we will join AC because AC is not still joined. Then come to B, BE already drawn, BD also already drawn. Then come to C, CE also drawn already when we were talking about E. Then CA also drawn when we were talking about A. Correct? Correct?
Yes.
Okay. So it will have how many diagonals? How many diagonals?
6.
Tell me how many diagonals?
5.
5 diagonals. Okay. Now come to this quadrilateral. This is also a quadrilateral. Am I right?
Yes.
Last time I asked you about this. Okay. This is also a quadrilateral. Correct? Correct?
Yes.
This is a quadrilateral because it is made up of, is a polygon. It is made up of line segment. It is closed. There is no crossing.
Close.
So
Simple.
simple, close, and made up of line segment, four-sided. So this is also a quadrilateral.
Yes.
And what about this diagonal? Yes, K and M are not adjacent vertices. So we join KM. Again, L and M are not adjacent vertices because L and M does not lie adjacent to each other. So LM is also a diagonal. For this type of quadrilateral, the diagonal is outside the quadrilateral, correct? One of the diagonal lies outside the quadrilateral, not inside the quadrilateral. For this type of quadrilateral, two diagonals lie inside the rectangle or the quadrilateral, PQRS. But for this KLMN quadrilateral, one of the diagonal lies outside the quadrilateral. So you already know what we mean by interior and exterior of a closed curve. Okay. whatever is inside the polygon or the closed, sorry, whatever is inside, it is talking about curve. So whatever is inside this curve is the interior of the curve, and whatever is outside the curve is called the exterior of the curve. Okay. The interior has a boundary, correct? Interior has a boundary, but the exterior doesn't have a boundary, correct? Exterior, when we talk about exterior, it can extend very far away. It can extend. Exterior means whatever is outside the curve. So it will not have boundary, correct? Boundary means it should be bounded within. But for the exterior, it is not bounded. But suppose it is drawn on a A4 paper. Suppose it is drawn on A4 paper. Whatever is inside the curve is the interior, and whatever is outside the curve up to beyond the boundaries of the A4 size paper, whatever is outside the curve will be the boundary of the exterior of the curve. Correct? Following?
Yes.
So let's discuss about convex and concave polygons. Are you getting whatever has been told? Whatever has been said? Everybody?
Yes.
So let's start
Yes.
convex and concave polygons. Here are some convex polygons and some concave polygons. This group are convex polygons and these groups are concave polygons. When we see the figure, just the KLMN quadrilateral, where one of the diagonal lies outside, like this one of the diagonal inside, one of the diagonal outside. Okay, this type are put under concave polygons, and for convex polygon, all the diagonals lie inside the polygon. So can you find out how this type of polygon differ from one another? What are the differences you see? So it says polygons that are convex have no portions of their diagonals in their exterior. Okay. For convex polygon, for this type of polygon, all the diagonals lie inside the polygon. And for concave polygons, every diagonal doesn't lie inside the polygon. Some diagonal lies outside the polygon. Study the figures, then try to describe in your own words what we mean by a convex polygon and what we mean by a concave polygon. Give two rough sketches of each kind. In our work, in this class, we will be dealing with convex polygons only, because whatever we have discussed about in few days back about parallelogram, rectangle, square, rhombus, every types were of convex type, not concave type. So let's see this figure. Look at this figure. How many sides this polygon have?
7.
7.
7 sides. So this is a heptagon. Am I right? Am I right? This is a heptagon.
Yes.
This is also a type of
Yes.
heptagon, but this heptagon is not convex, but it is concave. Okay. So what are the
Yes.
diagonals? What can be the diagonal? So these two diagonals, these diagonal I will draw. Okay. Better I will draw. This diagonal, and then sorry, let's start with this point. For this point, the diagonals are this one, this one, this one, and this one. The last diagonal that I have drawn, it is some part overlapping with the third diagonal, correct? Following? Are you can my sound reach you?
Yes.
Yes, हजुर
Okay. Then let's start for this point. This is one of the diagonal. That cover. Is my sound reaching you?
Yes.
Yes. So then this is also,
Yes.
yeah, this is also one of the diagonal. Then this will join this point. This will also join this point, diagonal. Like this, it will go on. Then this diagonal lies outside the polygon, the heptagon. So we can draw many diagonals, just to show you that some diagonal lies outside